they might have 3 or 4 vibration analysts on staff, people that they developed from engineering and from maintenance over time. They'd send them off to get certifications, and maybe they would be in kind of an apprenticeship mode until they can move into a senior analyst role. But long story short, it takes several years to develop an analyst. You can confidently look at vibration data in its raw forms and accurately identify faults.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined today by Chris Garrison, who has been on the podcast before. It's been a trend recently where we've been discussing how many times the guest has actually been on the podcast. I don't know if you remember, Chris, off the top of your head, how many times, because I tend to forget these things. But
Yeah, 3 or 4. 3 or 4. This may be the 4th time.
Yeah, there we go. And many more to come, I'm sure, as well, I'd like to think. But yeah, so today we're talking about vibration analysis, a topic you're very deeply involved in. I guess, we could go into sort of your background, Chris, and how you'll talk about this topic with customers as well is going to be of great interest. And of course, how it relates to predictive maintenance, of course, because that's why we're here, right? So, but I guess before we get started, Chris, maybe a quick intro from your side for people who may not have listened to your previous episodes before, just what you do at Siemens and that kind of thing.
Yeah, absolutely. Been working with Siemens and the Senseye product for roughly 3 years in total now, but have been in the predictive maintenance and condition monitoring space for 22 or 23 years now, which feels like a lot to say. But working with vibration analysis, instrumentation, and of course, platforms such as Senseye. So 22 years of kind of predictive maintenance and condition monitoring background.
And I guess, where did you first come across this term vibration analysis? Much earlier on in your career, I can only presume.
Yeah. In the beginning, it was lugging around kind of heavy recording equipment, data collectors, a lot of personnel going to take surveys on U.S. aircraft carriers. They would collect every machinery, collect data from every piece of machinery on an aircraft carrier once per quarter. It's called an MCA survey. And then they would bring all the recorded data back and analyze it and issue a report to help ensure readiness of the U.S. Navy. And come a long way since then, and how we gather that data and how fluid and how quickly we can respond and provide those types of details. But back in about 2004, I guess now, it really started with manual data acquisition and going back and digging into that data for weeks on end and providing manual reports.
And then what led you into sort of the world of predictive maintenance as well, then, just to bring the two together, I guess, early on?
I think, working with machinery and maintenance, and then joining an organization way back, ABB in the very beginning, just the interest of problem solving and, providing good, insightful information from the very beginning. I think the mission is very much the same today. Can we prolong asset life? Can we be more proactive in planning? Be less reactive? And I think that the goals are much the same, and they've evolved over time and gotten much more fluid and efficient. But it's always been gratifying work to be able to identify a potential or pending problem, head it off, and save everybody some time, headache, money, all of the above.
Oh, exactly. But I guess to move back towards the vibration analysis side. So I get this question might be obvious to many people listening out there. So apologies for this. So I'm asking it from my perspective and my understanding as a non-technical person, I guess. But what actually is vibration analysis, and how does it work? in reality?
Sure. So obviously, every rotating piece of equipment produces, vibration, movement, sound measurements, and from the shafting of the equipment spinning up and rotating within all of its confining components, such as bearings. Every moving part within an asset, provides some excitation, some movement, a signal that can be monitored. Maybe we touched on the history lessons in past podcasts, but it started with guys with a screwdriver to their ear, walking up to a machine and listening, and they could tell by the whine or sound of the machinery if it might have a bearing issue. And I think transferring that human ear, magnifying it, and moving into providing some instrumentation to actually cover more or all of the frequencies within a piece of equipment is really where that started.
And that's an interesting point as well. I mean, how, maybe we go into it deeper a little later, but how do you bring those two sort of close together? Sort of the technology side and the person who, like I said, it's almost instinct, right? It's someone who's known these machines for many, many years. And so how do you bring those together in reality?
Yeah, I think in the beginning, there was maybe some cautionary feelings about predictive maintenance, about how effective it could be. I think you had a lot of career engineers and maintenance managers out there that knew their equipment inside and out, and if they could hear it, that was good enough. And I think breaking through that barrier and showing them that with some acoustics equipment, with accelerometers and so on, you can learn that a little bit before your human ear can pick that up, and maybe we're 2 weeks out, 3 weeks out from what you might later pick up with your own ear. And I think that slowly you build that trust, and people realize that this equipment can obviously detect beyond what even maybe your best mechanic out there can hear with a screwdriver or with their ear alone. And I think it's a process. I think today, hopefully, vibration analysis is much more of a known and trusted entity, but maybe not always the case.
So I guess what are the because you sort of touched on it then. So what are the sort of misconceptions around vibration analysis? What presumptions are made, let's say, around it?
Yeah, I think that there has to be some care taken about the application, the instrumentation. I think that today, maybe more than ever, there are so many choices out there, and it's not really a one for one. Pick any sensor, put it on any machine. There's some solutioning there, and there's some considerations that have to take place. And I think that there have been times where sensors have been maybe just kind of thrown out in mass, put on equipment without too much thought or planning, and that could produce false positives, false negatives. Older engineer that I used to work with referred to it as whack-a-mole, having problems erupt all over the plant, and now this new vibration equipment is telling you you've got more problems, and how much of it is actionable. I think those are the cautionary tales. But the good news is, with proper planning, with proper solutioning, matching the right sensors to the right assets, we can absolutely avoid all of that. And I guess, as with most things, some of these lessons are learned the hard way.
No, exactly. And you mentioned one thing. An important part of the puzzle as well is selecting vibration sensors. So how can someone sort of go about choosing the right sensors for their particular use case, the right vibration sensor, I should say.
Yeah. Just preceding our podcast here, we were spending a good hour or two on this very subject, and there's a lot to decipher in different spec sheets and different things out there. We have a lot of Siemens and Senseye approved partner solutions where we kind of vet them and match them to different asset classes. So there are certainly folks on our team that can delve in and help with that process. We also, try to provide some straightforward material to that end to help you make some decisions about sensors and instrumentation. But yeah, I think that it's something everybody who is in the position of choosing sensors should educate themselves a bit, and certainly I hope we can help with that where possible.
And then I guess, yes, so again, selection's the first thing, but you mentioned also about sort of the rollout process and, whack-a-mole. Well, I do love that. I'm going to take that one away, I think. We'll be into future podcast. But that sort of strategy. So what, I guess why do a lot of organizations approach it that way? Just roll it out as far and wide as they can. And what should they be thinking about instead?
Yeah, great question. So, ROI, I think, is top of mind, right? Maintenance budgets can be some of the first under threat. Um, if you're going to have a capital expense or an operational, OPEX expense for these sensors, where are you going to get the greatest payback? Where are you going to get the greatest justification? So looking at things like machine criticality, what assets within your facility are going to stop the show, if you will. That might be one of the best places to start to get that return, and then kind of moving outward from there. So we're starting a brand new discussion with a facility. We might say, have you done criticality assessment just yet? Surely maintenance and operations and everyone knows what's most critical in there, to their operations and what can shut down the plant. But, seeing if maybe they formalize that process and we can get a look at what's most critical and what challenges might exist around those assets.
And if we talk about vibration analysis again and industrial equipment, so why is it so important? Because there's lots of different types of analysis that could be done and lots of different data types. So why does vibration stand out with certain use cases?
Yeah, there's lots of great PDM technologies. Vibration just seems to stand the test of time of being the most encompassing. If you have to choose one technology that can identify, the most fault modes within a piece of equipment, it's generally vibration. If you have hyper low speed equipment or different types of assets, you might be able to use thermography, oil analysis for some of these gearboxes and things. But most of the other predictive maintenance technologies are rather niche, if you will. They're targeted to specific assets or specific problem statements out there, ultra low speed equipment and so on. Vibration just kind of seems to be the overall, I don't want to say one size fits all, but it's the most encompassing of the technologies.
Yeah, and encompassing is maybe the right word. In the sense, does it cover certain machine types or certain industries? But I guess what you're saying, Chris, is no. It's very sort of broad, can be broadly applied. Maybe.
Yeah. There's a lot of commonalities in equipment. Certainly, there are considerations from different verticals, whether it's food and beverage, oil and gas, auto manufacturing. But in the end, we've got typically motors. Driving different pieces of equipment. And the considerations really are in how variable that equipment might be in its operational environment. Does it change speeds a lot? Does it run at ultra low speeds? Is the environment, particularly harsh? Are there really high temperatures, really low temperatures, and so on? So, yeah, I think you're considering all of these things. We're putting calibrated sensors and things out into these industrial environments, and they've got to be able to stand up to the elements. So that's one consideration.
And I don't know if it's the right way to phrase, but do you often get sort of questioned about why vibration analysis versus another type of analysis? I know it's always a discussion with the customer and finding out what's best, and obviously there's a reason why they work with vendors like Siemens to provide that sort of. advice. But is there any sort of question marks against vibration analysis?
Yeah. I think, especially today, you've got these kind of inherent data points that are available from the OEM. Maybe you have some kind of vibration data already provided as part of the package from the motor, manufacturer. Maybe you have current and temperature and some of these other things. So what we really do is look at failure mode or fault mode coverage. If we've got a small, highly efficient servo motor, maybe criticality or replacement cost is rather low, and we've got current and temperature, and we can calculate torque and things of that nature. Maybe you don't need vibration, right? That there is an expense associated with instrumenting. You don't have to put a vibration sensor on everything, particularly in our world. Thankfully, for Senseye, we can work with the data that is available from those motor manufacturers or from those equipment manufacturers in general. But as you move on to larger equipment, or as you look to being more encompassing with fault mode coverage, it's not really a stretch to where you start to look at vibration analysis to fill in those gaps to cover more failure modes.
And when implementing sort of either vibration sensors or vibration analysis, what's some of the sort of challenges or things organizations sort of need to consider before, sort of going ahead with that?
Oh, loaded question. Very loaded question.
I don't try to.
No. I think cooperation across different departments and different stakeholders within an organization is very important. Having IT and those involved with data security involved from the very beginning, understanding and assessing, whether data can be moved to the cloud fluidly, or whether it needs to be stored on the edge and maybe moved a different way. So data architecture, in short. And then, of course, machinery. There is data interpretation and analysis, right? Who's going to take action on the results, that are put forth by a platform like Senseye. How might you feed information back into the platform to kind of close that loop, right? Let's say a fault has been identified, maintenance has gone out and they've corrected it. Closing that loop might be having the work order information fed back into a platform like Senseye, where you kind of close the loop and say, yeah, that problem was confirmed. We changed the bearing or we swapped the motor, and we're off and running. So maybe a long-winded answer there, but going back to your original question, having maintenance, plant management, having everyone on board, I think from the beginning is very important, because it really takes that kind of cross-department cooperation, I think, to be successful.
Yeah, no, absolutely. It's something we often talk about on this podcast as well. The importance of alignment. Don't try and start these projects or continue these projects without alignment with other stakeholders. But maybe you could sort of talk us through sort of a typical implementation of vibration analysis, Chris. What if there is a typical? And I know no project is the same, right? But maybe there's an average you could take.
Yeah. I really think it starts with an asset list. What equipment is in scope? What equipment is already being considered? Is that asset list really encompassing all of the equipment that could be monitored or should be monitored? Again, back to criticality. What's most important to the facility and the operations? I want to clarify, I guess, that vibration analysis and predictive maintenance in general certainly doesn't have to just be applied to your most critical assets. I think we talk about it as a starting point. And when you're doing things like putting on vibration sensors onto equipment, you do have some expenditures there to consider. But even the least critical type equipment, is a potential candidate for predictive maintenance. I think you're just at that point thinking about spend, right? Do you want to add additional instrumentation? What can be done with the data environment you have today? I think we talk a lot about that. Going back to whatever data might already be there from the OEM that's being fed into a DCS system and so on. But yeah, you can do a lot with the data you currently have, and then go to vibration from there. So back to the asset list, criticality, um, return on investment, maybe cost versus benefit for vibration, and then digging into the characteristics of that equipment. How does it operate? Does it change during its operational characteristics frequently? Does it ramp up or ramp down in speed? Um, again, maybe kind of repetitive, but the environment, how harsh is it? Is it maybe an ATEX hazard rated environment? Do we need to have special equipment that is explosion proof or spark proof? All those things. So much there.
Yeah, that is a lot of detail. And that's why there's scope workshops to go through all this in great detail, right?
Absolutely.
And then, you talked about right at the beginning of the podcast, you talked about the person walking around, getting a feel for the machine and things like that. And of course, we're in an age of AI or cloud as well, but AI and cloud. But how have those two technologies or elements, how have they sort of transformed vibration analysis in your view?
Oh, yeah, some fantastic changes there, right? Going back to the old naval environment or marine environment, I first kind of entered into where people went out and collected data, and it may be weeks really before you had some interpretation of that data, and before you were able to act on it. And you know, failure mode progression rates can certainly vary greatly, and some things may already fail by the time you really complete that round trip and get an actionable report in the right hands, so somebody can do something to be preventative, to be proactive. Um, but with cloud environments, you can bring the experts right to your plant. You can deploy some of the most advanced analytics. A platform like Senseye is always evolving, right? Software updates are fluid in the cloud. New feature, new development, new function is right there and ready. No more, deploying kind of that bulkier on-site software upgrade. So I think you move data from the plant floor to the cloud to the experts, through the best analytics packages there are out there, and you can be alerted in minutes or hours of impending, faults and problems developing.
I guess has it enabled the sort of scalability of vibration analysis as well? Whereas it might be done very on limited numbers of assets and things like that. But I guess that's one thing that's a real benefit, right?
Yeah, and I think there's a limited amount of people that are interested in going out and kind of making a career out of vibration analysis and becoming level 3 and 4 certified experts at data interpretation. And I think that this really bridges that gap and allows you again to kind of bring the expert right into any size facility, whether it's a small pumping station somewhere, relatively small plant where you wouldn't employ a vibration analysis, or excuse me, a vibration analyst, and maybe you wouldn't pay the expenses to have someone come in remotely periodically. You can now put in some cost effective equipment and some kind of architecture to just bring data to the cloud and monitor that from wherever you are in the world.
You mentioned that vibration analysis, so that a person doing the analysis, is that usually an in-house role or someone who's brought in sort of externally, or can it sort of depend? It could be either way.
Yeah, I would say it greatly depends. 15, 20 years ago, if you went to a very large plant that maybe had thousands of assets, um, I think of things like oil and gas, Chevron Phillips, and the like. They might have 3 or 4 vibration analysts on staff, people that they developed from engineering and from maintenance over time. They'd send them off to get certifications, and maybe they would be in kind of an apprenticeship mode until they could move into a senior analyst role. But long story short, it takes several years to develop an analyst who can competently look at vibration data in its raw forms and accurately identify faults. And I think that's another area where, of course, AI and ML are helping bridge the gap a bit. But there is still some human element to data analysis and making some decisions as far as vibration goes. Some of it's still somewhat subjective, and it's a good idea to have somebody at least familiar interpreting results and recommendations.
Yeah, and of course, as we know, Senseye is very much a decision support tool, right? And any AI technology is there to be supporting or to give you a different viewpoint. Like if you were talking to a colleague, you could could ask their advice and their experience, but you're asking AI for that advice instead.
Yeah,
With obviously the difference that they've got all the knowledge of it, in theory, all of the assets as well. So
exactly.
that's the way to position it, right?
Yeah, and I think there's so many intriguing things ahead in that regard. Um, different facilities have different maintenance strategies, right? Where one plant might simply dispose of a motor and replace it outright. Another plant might service that motor, and actually replace bearings, for instance. Another might be less risk tolerant to a developing fault. And in the first sign of a problem, they might change out that asset or do something um, rather substantial to head off a pending fault. And others might be more accepting of risk and run things closer to failure. I think it varies so greatly that it's hard to have just a canned AI engine that says this is happening, do this. But now with things like Copilot and generative I think we can get a lot closer to AI understanding that based on the work order history and all the things that this facility does, this is the relevant and relative action item that should be performed, if that makes sense. So much more of a hands-on, maybe intimate um, type of recommendation versus a one-size-fits-all.
Exactly. Not just generic advice, but advice very much contextualized to your assets, your organization, and the knowledge of your maintenance teams, as an example.
Yeah, I think that's a perfect way to put it.
Yeah. No, fantastic. So, yes, so it looks like we've come to the end. It's been really great to learn about this subject, Chris. Thank you so much for joining us and giving us the lowdown on vibration analysis as well. But yeah, thank you for your time, and thank you everyone out there for listening, and we'll see you on the next episode. Thank you very much.
Thank you.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.
they might have 3 or 4 vibration analysts on staff, people that they've developed from engineering and from maintenance over time. They'd send them off to get certifications, and maybe they would be in kind of an apprenticeship mode until they can move into a senior analyst role. But long story short, it takes several years to develop an analyst who can competently look at vibration data in its raw forms and accurately identify faults